Okay, we are going to be learning about equations with radicals and exponents. And our very first step is, when we're solving these equations, is to take a look at our radical and determine the domain. So we're going to be determining the domain, and I'm going to add something here, of even roots. That means when the index is even. And that's because when the index is even, our radicand needs to be positive. So when the index is even, our radicand is going to need to be positive. So these are the steps we're going to take. First step is we're going to set the radicand. And let me show you what the radicand is. The radicand is the value that's inside that radical symbol. We're going to set the radicand greater than or equal to 0. You might be saying, how can I set it greater than or equal to? What does that mean? It's this symbol right here, greater than or equal to. Greater than or equal to 0. Then we're going to solve the inequality that we created from step 1. And step 3, we will write the domain in interval notation. So we're going to get some practice here with interval notation. Okay, let's get started. We want to determine the domain of each one of these radical expressions. First thing I'm going to do is I'm going to highlight the radicand. The radicand in number 1 is x minus 5. I am going to take that radicand, x minus 5, and I'm going to set it greater than or equal to 0. I'm going to solve that inequality by adding 5 to both sides. So I get x is greater than or equal to 5. Now on a number line, I've got negative infinity on the left and positive infinity on the right, and I've got 5 somewhere right about here. Greater than or equal to 5 would include 5, and then it would go greater than, which means it's going to go towards positive infinity. So as an interval, that closed dot is a bracket. And then, of course, infinity is always going to be parentheses. So we will have a bracket, 5, comma, infinity. And that means include 5, and any number 5 towards infinity will work. Okay, let's try another one, number 2. Now, we had an even root, again, an even root, and that's what we're looking for here, is domains of even roots. And that's because they have restricted domains, because their radicand has to be positive, or it can be 0. So again, we're going to take that radicand, 3y plus 15, and we're going to set it greater than or equal to 0. Now I'm going to solve it. 3y is greater than or equal to negative 15. I'll divide both sides by a positive 3. And I get y is greater than or equal to negative 5. So on a number line, we'll have negative infinity on the left, positive infinity on the right. Negative 5 is somewhere between. Greater than or equal to would be a closed circle because it's equal to negative 5. And then greater than would shade towards positive infinity. So our answer, we'd have a bracket at negative 5 and a parenthesis at infinity. So we have bracket, negative 5, infinity. Now be careful here, because you might be thinking, well, I'm always going to have something getting greater than or equal to, so it's going to be greater than or equal to some number, so I'm always going to have infinity on the right. But here's a case where you might not have infinity on the right. We've got the case here where I've got 8 minus 2y, that's my radicand. I have an even root So I have this even root right here. So I'm going to take the radicand and I'm going to set it greater than or equal to 0. I will subtract 8 from both sides, and I get negative 2y is greater than or equal to negative 8. And now I'm going to divide both sides by negative 2. But remember, when we take an inequality and we divide or multiply both sides by a negative, we need to flip the inequality symbol. So I have y is less than or equal to negative 8 divided by negative 2 is positive 4. So when I draw my number line here, negative infinity on the left, positive infinity on the right, 4 is somewhere between. Now it's y is less than or equal to 4. So equal to is going to be a closed dot, but less than is going to go towards negative infinity. So now I have a parenthesis at that arrowhead, and I have a bracket at 4 to include 4. So from the left, negative infinity to positive 4 with a bracket. Now what's different about number 4? Number 4, I've got the radicand, 2x minus 9. Nothing different really there, but we have an odd index. That means an odd index means the radicand can be all real numbers. It can be from negative infinity to positive infinity. So since it can be all real numbers, you can have negative numbers in there, positive numbers, in an odd index, then our solution just goes to negative infinity to positive infinity. Number 5 is another example where we're going to have something interesting happening. X squared plus 9. And then again, I've got this time an even index. So I'm going to write this down. I'm going to start using some different colors here. X squared plus 9 is greater than or equal to 0. So let's think about this. X squared plus 9 is greater than or equal to 0. Subtract 9 from both sides. X squared is greater than or equal to negative 9. Well, if I take a number and I square it, if I take a positive number and I square it, I'm going to get a positive. A positive is greater than negative 9. If I take a 0 and I square it, 0 is greater than negative 9. Heck, if I take a negative number and I square it, a negative number times itself is positive, and positives are greater than negative 9. So when I go to draw this number line and I say what numbers will work, all negative numbers work, 0 works, all positive numbers work, all these numbers are going to work because any number that's squared is going to be positive, and all positive numbers are greater than a negative. Therefore, our domain is going to allow any number from negative infinity to positive infinity. Now, if you want to try number 6 and see which one 6 kind of looks to check your understanding, go ahead and try it, press pause, then come on back and check your answer. Okay, if you're back, I'm going to come over here and I'm going to write that this is true for all real numbers. And that's why we got negative infinity to positive infinity. Number 6, I have an even, nope, I've got an odd index. If it's an even index, I have to go through that inequality, but an odd index, negative infinity to positive infinity is our domain. That means all real numbers will work. So what did we find here in each one of these cases? we found the domain, the domain, the domain. And we found the domain two different ways. And if you made the number line, you actually represented it a third time. So purple's my favorite color. So I'm going to show you how else we showed the domain. The domain we showed as x is greater than or equal to 5. Here we showed it y is greater than or equal to -5. Here we showed it y is less than or equal to 4. On number 5, we said that this was true for all real numbers, so all real numbers is another way to write that. And let me show you here, all real numbers is how you would write negative infinity to positive infinity. All real numbers. Now, I highlighted those because those are our inequalities. However, we wanted to write the domain in interval notation, so that's what I boxed. So interval notation was our boxed answer in each and every case. Now, in the next video, we're going to start solving some radical equations.